Welcome to this Kavhanna Explainer. Today we're cracking open the internal strategy documents for a technology called STELOS. We're going to trace its engineered future, a path that's not just a dream, but is already funded and in motion. You see, this isn't about what might happen, it's about what is being built right now.
So let's start with a number, 2.4%. And I want to be crystal clear about this. This is not some theoretical calculation, it's not a computer simulation, and it's definitely not a goal for the future.
This number is a hard, empirical fact. It's the validated system efficiency. As it's all laid out in Document 5, this 2.4% has been confirmed today through rigorous, real-world testing. It is our ground truth, our starting point.
And from this exact point, the path forward isn't just a proposal. No, it's an engineered, fully funded reality that's already moving. The climb doesn't start tomorrow, it starts right now, from this proven foundation.
Okay, so, Section 1, the validated foundation. Before we look forward, we have to understand the non-negotiable, proven ground that we're standing on.
And here's the raw data straight from Document 5. You've got that system efficiency of 2.4%. Then there's the ZT figure of merit at 1.4. Now, the easiest way to think of ZT is as a raw performance score for the material itself. You know, how good it is at turning heat straight into electricity. The higher that ZT number, the better it works. And finally, a projected MTBF, that's mean time between failures, of 2,200 hours. Remember, these numbers aren't the goal. They're the starting line.
Which brings us to Section 2, the engineered trajectory. Now that we've established our base camp, we can look up at the mountain and see the path to the summit.
This really puts the whole journey into perspective. We're starting in 2025 with our proven 2.4% efficiency and that 1.4 ZT score. The destination, the horizon for 2040, is an efficiency of over 7.2%, and that is all driven by getting the ZT to over 3.5. Now, a jump like that, more than doubling the material's core performance, that's a fundamental leap in physics that makes this entire climb possible.
There's a line from the strategy overview that just perfectly captures the whole mindset here. The roadmap is not a plan, but an inevitable trajectory already underway. It's happening.
Okay, Section 3, the R&D escalation. So how in the world do they get there? The answer is in what they call the engine of perpetual optimization.
This number is the proof. $890 million, that's the total committed investment for the R&D roadmap we see in Document 11. This isn't wishful thinking. This is the fuel for that engine.
And that money is powering a very deliberate, phased approach. You can see the roadmap is broken down into 4 clear stages. It starts with the foundational work that's happening now, moves through expansion and consolidation, and it all builds towards a final phase of disruptive innovation. This is a long-term strategic climb.
The first vector of this whole R&D push is a flat-out revolution in material science. This is the absolute bedrock of the strategy. It's how they're going to push that ZT score past 3.5 and just shatter the current barriers.
And the goals here are just incredibly ambitious. It's not just about hitting a number in a lab. We're talking about developing things like self-regenerating composite materials and integrating metamaterials to actively control heat on the fly. They're not just improving the system, they are fundamentally redesigning what it's made of.
So, Vector 2 is all about giving the system a brain. We're going to see it evolve from just a passive piece of hardware into a truly intelligent, adaptive network.
Yeah, this is where the system really comes alive. Think predictive AI, swarm coordination between different units, and eventually, complete autonomy. They're planning to use digital twin models, basically perfect virtual copies of the live system, to constantly run simulations and find the next tiny little point of optimization.
And the final piece of the R&D puzzle is all about creating a system that not only performs, but lasts. This is the path to building something that can, for all intents and purposes, heal itself.
And you can see the planned evolution right here. It starts smart, with modular design and predictive AI, but the trajectory is aimed at true material self-repair, which all culminates in a fully autonomous, self-regenerating system. This is how you achieve almost unbelievable operational uptime.
Which brings us to our final section, the horizon of dominance. We've seen the foundation, we've seen the engine.
So now, let's look at the inevitable conclusion of this engineered ascent.
The target at that horizon begins here, a total system efficiency of over 7.2%. A feat that's unlocked by that material science breakthrough, a ZT figure of merit over 3.5.
And it all leads to a system that is built for just extreme endurance, with a target mean time between failures of 8,000 hours. That's nearly an entire year of continuous, uninterrupted operation.
And this is the final state of the system at the horizon. Self-optimizing, self-diagnosing, and self-preparing. It's a system that needs zero direct human oversight to do its job.
But maybe the most telling, the most important line in this whole strategy is this one. The summit is not an end. It is the next foundation. Reaching that 2040 horizon, that's not the finish line. It's just the base camp for the next climb. That is the very definition of perpetual optimization.
So, the trajectory is set. The engine is funded and running. The horizon isn't just a distant dream, it's being actively engineered into reality. And the only real question left is, once they get to the top of that first summit, what will they build from there?